In this question, our customer may get the cash coupon. It depends on their spending amount, and then the corresponding percentage is given like this. You'll find that it's add them together is not equal to 1. It's because there is some chance that they don't get any coupon. And this probability is 0.45, 0.2, and 0.1, 1 by 1. So in case that they spend less than 500, then we use all possibility to exclude all this. We get 0.25. Now we are going to assume the number of transactions per minute follow a Poisson distribution with the mean 2. Part A, they just simply ask you that the number of transactions. So this is totally not related to part A. We focus on part B. But beware that X is already occupied for the transaction amount. So we better let another unknown. Let's say we let the random variable be Y. And we know that Y follow a Poisson distribution with mean 2. In part A, the required probability is equal to P, Y, at most 4. That means smaller than 4 or equal to 4. Again, double confirm with the wording. At most here, do we accept the equal case? In this case, we accept it. So we break it down. That means we consider the case from Y equal to 0 until Y equal to 4. E power of negative 2. And then we have 2 power of 0 over 0 factorial. 2 power of 1 over 1 factorial. Seven times of e power of negative 2. 0.947346982. In part B, we are going to find out the probability that there are exactly 3 transactions, which is about Y, and also the second stage is the cash coupon of the total value $200 are issued. In mathematical expression, that means it's like this, and these two events are not independent. More customers should imply a higher total value of the coupon issued. So the calculation is we ensure the first stage, and then the second stage we are going to consider the conditional probability. Again, we are going to break down the calculation. The first part, y equal to 3, is easy. It's just e power of negative 2, 2 power of 3 divided by 3 factorial. 4 over 3 e power of negative 2. The most difficult thing is to handle this conditional probability. Given that y equal to 3, that means there are 3 spaces, each space representing the cash coupon of each customer that they get. In order to get the total value of 200 cash coupon, maybe the first one get $200 cash coupon, then another 2 need to get 0 cash coupon. This is the first type. But there are some possibility that maybe the first one gets 0, second get 200, and the third one gets 0. Are also regarded as the first type. So we are going to multiply how many paths that can fulfill this requirement. If we count it, we have 3 spaces. So we have 3 factorial paths to rearrange it in the beginning. But however, 2 of them are the same. So we have to divide the duplicate result, which is 2 factorial. In short, that means we have 3 paths to fulfill this requirement. Then we think about the second type. If it is not 200, maybe 100. So if this is 100, then this one may be 100. Then the last one should be 0. Now we are going to count how many paths can achieve this target. Again, we have 3 space, 3 factorial, and then divided by 2 of them are repeated, so divide by 2 factorial. The next type, maybe this one is still $100. And then this one no longer 100, otherwise it is the second type, so we choose 50. Then we have the last one also 50. The number of paths is equal to 3 factorial divided by 2 factorial also. Now we look for type, the fourth type. If it is 100, if this is 0, then the next one is 100. So it's duplicate the second type, this is not a new type. And then you try for a few times, you'll find that there are only 3 types here. Therefore, this passes the probability. Let us consider the first type, 200, 0.1, and $0, 0.25 for 2 times. 0.1 and then 0.25 for 2 times in a row. And this number, it seems like the coefficient NCR, something like that, but we use a specific method to count it. It's 3 factorial divided by 2 factorial. Now the second type we write in the second row is 100 2 times and then 0 1 time. So we have the corresponding probability 0.2 square, 0.25 power of 1. Again, it's 3 factorial divided by 2 factorial path. Last one. 100 appear 1 time, so 0.2. 50 appear 2 times, so it is 0.45 power of 2. The number of paths, 3 factorial divided by 2 factorial. Then we just use calculator. It's 0.17025. Then we go back to our required probability. We just multiply the 2 intermediate results and then we get 0.030721109. Part C are similar to Part B calculation. Now there are exactly 4 transactions instead of 3. And then we are going to find the probability that the cash coupon of total value 200 are issued. But pay extra attention is they have the word if. That means the first stage already ensured. That means we just talk about the conditional probability at the back, but not the first stage. So what we are calculating in Part C is the conditional probability given that y is already confirmed equal to 4. What's the chance that the total value of Q point is equal to 200? Again, in our draft, we have to reserve 4 space, and then we are going to find out some combination. How many combinations will fulfill our target? Like what we have finished just now. So I think that the first combination may be again 200, 0, 0, 0. How many times we can rearrange them? We have 4 factorial paths, but 3 of them are the same, so we have to divide the duplicate result divided by 3 factorial this time. Next type may be 100 now, and then this one can be 100, and then we have 0, 0. Again, the number of paths, we have 4 factorial divided by this 2 is duplicate, so we have to divide by 2 factorial. And at the same time, this 2 is also duplicate, so we divide by another 2 factorial. The first case may be the first one is 100, and then this one no longer 100, and then we choose 50. So another one is 50 and 0. The number of paths 4 factorial divided by these 2 are duplicate, so we divide by 2 factorial. The fourth one, it seems that we use all the combination. If the first one is 100, then we choose 50. 50, 50, 50, and 50. So this is 4 factorial, but 4 of them are duplicate divided by 4 factorial. That means only one single path to fulfill this requirement. There is no other path you can add together to get 200. But of course you should spend more time, a little bit more time to confirm. But if no more path, then we start working now. The first type 200 appear 1 time, 0.1 path 1. And then 0 appear 3 times, 0.25 appear 3 times. The number of paths 4 factorial divided by 3 factorial. The next type 100, which is 0.2, appear 2 times. $0, which is 0.25, appear 2 times. The number of paths is 4 factorial divided by 2 factorial divided by 2 factorial. Third type 100, which is 0.2 1 time. 50 2 times, 0.45 path 2. And finally $0 appear once. Number of paths is 4 factorial divided by 2 factorial. Last one, $50, 0.45 appear 4 times in a row. Number of paths is 4 factorial divided by 4 factorial. Is equal to 0.1837565. Finally, they are asking for a conditional probability, given that there are most 4 transactions. In this situation, find the probability that the cash coupon of total value 200 are issued. For a conditional probability is equal to the n case and then divided by the probability of given case. Now the given case is at most 4 transactions. Y is smaller or equal to 4. This part it should be exactly the same as your answer in part A, so just by applying the answer in part A you will get 1 method mark. N case here mean Y is smaller or equal to 4, at the same time total value equal to 200. It's not easy to handle the inequality in this condition, so we are going to separate to different case. The first case, Y is equal to 0, at the same time total value equal to 200. But it's so stupid, it's because no customer, how can we give the coupon? So this is rubbish. So we have 4 different cases may fulfill the requirement. And you may notice that this case is what we get from part B. This case is not exactly the same as what we give here. It's because in the part C, we didn't ensure Y is equal to 4. We just calculate the conditional probability. So pay extra attention about that later on. The first case, only one customer, e power of -2, and then we have 2 power of 1 divided by 1 factorial. And that person, that single person, must get $200, so we have to multiply 0.1 for the cash coupon. Now the second case. Ensure the first stage, we have 2 customers, so 2 power of 2 divided by 2 factorial here. You may need to break down your calculation. In exam, it's fine that you use some empty space below to finish some intermediate steps. So, given Y is already confirmed 2, to get $200, we use 2 space. First example, $200, $0. Second example, $100 and another $100. If it is 50, it's just impossible. If it is 0, it's go back to the first type. So there are only 2 types. The first type 200, 0.1 times 0, 0.25. The number of paths is 2 factorial. The second type, we have 100, 0.2 in a row. So the number of paths is 2 factorial divided by 2 factorial. It is 0.09. So this is 0.09 and we finish the second case. The third case is the answer of part B, so we just copy down. And the last part, don't forget that we didn't confirm the first stage situation. Therefore, we are going to write e power of -2 and then 2 power 4 divided by 4 factorial. Probability in part C, 0.1837565. Divided by answer in part A, that means 7 e power of -2. Then we use calculator. The final answer is 0.104214881. You may copy down your inserted result somewhere before, but this part don't deserve any mark anyway.